Okay, so this particular chapter is on finding angle measures within a circle, whether they're formed by secants, tangents, or just chords. So this is an example of two secants, and the angle is not in the center of the circle, it's not on the circle, so it's not an inscribed angle, it's just an angle formed by a secant and a secant. So if we are looking for the measure of angle 1, the formula for this type of angle is arc plus arc divided by 2, and that'll give us the angle. And the arcs that I'm referring to are the arcs that are across from the angle. So I can say the measure of angle 1 equals arc AB plus arc DE divided by 2. Okay, so let's see this as an example. So we have a secant and a secant, or we have a chord intersecting another chord, and this is where we will have arc plus arc divided by 2. So the arcs across from X are the ones that we will add together. So arc 130 plus 84 divided by 2 will equal X. So X will equal 107. And that was just straight calculator work. So I would like for you to do the next example, and you will have to solve for X. Pause the video and see if you get the same thing that I do. Okay, if you did not get 123, raise your hand and please let me know why. Okay, the next example is really actually just an inscribed angle. So if we have a secant and a tangent, then the secant and the tangent will form inscribed angles, just like we did before. So if we were looking for the measure of angle 2, if you can see the blue arc, the measure of angle 2 will just be arc BCA divided by 2. And the measure of angle 1 will just be arc AB divided by 2, because it's an inscribed angle with the vertex on the circle. So I guess our overall formula is that angle equals arc divided by 2. So nice and easy, if we wanted to find angle QPR in this example, we would take 148 and divide by 4, or divide by 2, sorry. So the measure of angle QPR will be 148 divided by 2. So that will give us 74. Measure of angle QPR will equal 74. Okay, so if the inscribed angle is half of the arc, then when we want to find the arc, we would just double the inscribed angle. So if we want to find arc FD, we would double it. But this question is asking us for the measure of arc DEF. So I'd like for you to pause the video and see if you get the same thing that I do. Okay, and I got 232 degrees. If that's not what you got, go ahead and raise your hand. Okay, so we really need to pay attention to where the angle is. Now we're looking at the angle and it is outside the arc, or outside the circle. So if the angle is outside the circle, then we're actually taking like money out of your pockets. You're taking away from. This is going to be a subtraction problem. So this one's going to be arc minus arc divided by 2 to get angle A. So angle A will equal arc minus arc divided by 2. And you have to take the larger arc first and subtract the smaller arc. So you're going to go kind of in the direction of the angle. So it would be arc DE, the bigger arc, minus arc BC. And it has to be in that order. So in this example, we have arc 110 minus arc X divided by 2 equals 25. Then of course, to get rid of this 2, we would just cross multiply here. We've got 2 times 25 is 50 equals 110 minus X. And we will get that X is 60. Okay, so I would like for you to try the next example on your own. This time we're going to look for the measure of angle H. Pause the video and see if you get the same thing as me. Okay, we should have gotten that the measure of angle H is 31 degrees. All right, and then another example of when the angle is outside the circle. Again, the angle is outside of the circle, and this is a secant and a tangent. We're doing the same exact thing. You take the big arc to find angle A. You take the big arc, so DC, minus the little arc, so BC, and divide by 2. So angle A is arc minus arc divided by 2. So again, if we want to look for LP, arc LP, we can call it X. Since X hasn't been used anywhere else in our picture, we would do big arc X minus little arc 78 divided by 2, and that'll equal the angle 36. Okay, we can go ahead and cross multiply here. 2 times 36 is 72, which equals 1 times x minus 78. So x minus 78. So then we would go ahead and add 78 to both sides of our equation. And we get x is 150. Okay, so same exact process. We're looking for arc QTS. Go ahead and pause the video and see if you get the same thing that I do. Okay, and you should have gotten that the measure of arc QTS is 248. Okay, and the next example we're going to look at is again an angle outside of the circle, this time formed by two tangents. So we're following the same process. It's big arc minus little arc divided by 2, and that will equal the angle. So in this case, angle A is going to equal big arc BDC minus little arc BC divided by 2. Now, the only thing that's kind of tricky about this is that since these are two tangents, they don't have to give us all of the information that you think we would need. They only have to give you one piece of information. Because if this section of the circle is 106, then we can figure out what the remaining XZY is, because the total circle is 360 degrees. So if the whole circle is 360 degrees and they already gave us 106, then that will be what's left over of the circle for XZY. So 360 minus 106 is 254. So they didn't have to give us that missing information. So that covers XZY, which is 254. Now that we know that XZY is 254, we can do arc minus arc, so 254 minus 106 divided by 2, and that'll equal angle W. So 254 minus 106 divided by 2 gives me 74. So angle W is 74 degrees. Another little trick, and I don't like to teach this because then everybody starts to get confused, but if it works for you, if they give you this arc here and the angle, these two actually end up equaling 180 degrees every single time. Now, that's all fine and well, but in this picture you don't have the missing arc, and a lot of my students will say, oh, I just subtract 180, but they'll make the mistake of doing it from the 290. So if you're going to do anything with 180 degrees, you need to work with the one that is right next to the outside angle. In this case, we don't have it. So we would take the 360, subtract what we do have, which is 290. 360 minus 290 is going to give us 70. So this arc right here would be 70 degrees. Now you can say these two are actually equal to 180. It's just a rule that ends up happening due to the way that the circle is divided out every single time. So if x plus 70 equals 180, then x would be 110. And we can go back and do it the other way too and say that arc minus arc, so 290 minus 70 degrees divided by 2 will give me angle, or will give me x. And the math will work out the same way. 290 minus 70 divided by 2 does in fact equal 110 degrees.